Hello everyone. Last class we had a discussion that iron losses in open circuit test, right? So we are conducting a open circuit test. From that open circuit test we are having iron losses, and in addition with that iron losses we are going to get what? Shunt branch parameters. Those are nothing but R0, X0, and it's time to discuss separation of those iron losses which are from open circuit test. So in order to separate iron losses into hysteresis and eddy current losses, this open circuit test is conducted with variable voltage and frequency, such that V by F should be constant. So what is the open circuit test? In open circuit test, we have provided the rated voltage, and what about the frequency? Frequency is nothing but rated frequency to maintain what? Flux constant, right? That is V by F, which is equals to B max should be equals to constant, right? So from this we are going to get iron losses. Right? So these iron losses can be categorized into hysteresis and eddy current losses. Then how can we separate these losses into hysteresis and eddy current losses? So in order to separate these losses, we have to provide variable voltage and frequency. Variable voltage and frequency to separate these losses. Frequency and voltage should be varied. In any case, we have to maintain V by F should be equals to constant. So for different instance, we have to provide different voltages. In accordance with the variation of voltage, the frequency has to be changed. Then only we are going to get the constant V by F. Okay. So this is the procedure. So apply rated voltage and rated frequency and note down the wattmeter and frequency meters. So we have provided P rated and F rated. Then note down the readings of wattmeter. Shows what? Iron losses, right? And frequency values by using frequency meter, right? Then apply reduced voltage and less than rated frequency such that V by F is maintained as constant, and note down wattmeter and frequency meter readings and repeat this step for various values of V1 and frequency, keeping V by F constant. So first we have to conduct the test at rated voltage and rated frequency, and further noted the wattmeter readings. Those are nothing but iron losses, and from frequency meter you have to read the frequency values. Then later stage, repeat the step with the voltage which is less than rated voltage and frequency which is less than F rated, right? Previously V is equals to V rated, F is equals to F rated. Now second case, we have to take the readings when we provide the supply voltage which is less than rated voltage, and like that we have to provide the frequency which is less than rated frequency. That is, let us take an example. The frequency should be V by 2 and F by 2, right? For this case, what is V by F? V by 2 by F by 2 should be equals to what? V by F, which is equals to constant, right? Which is equals to constant. For example, later stage, I would like to decrease the rated voltage by 1/3 value, that is V by 3 but F by 3. What is the value of V by F? Is there any change in the value of magnetic flux density? There is no change in the value of flux. In any case, V by F is constant. Now V by 4 F by 4, that is V by 4 F by 4. At any case, the voltage and frequency ratio is maintained as constant. So similarly, at any case, V by N F by N, if we reduce the rated voltage by N times and reduce the frequency by N times, at any case the value of V by F, which is equals to B max, which is equals to constant. So like that, we have to take the different values of voltage and frequency and note down the readings of wattmeter and frequency. For different values of voltage and frequency, we have to note down the readings of wattmeter and different frequencies. So after getting different values of power losses and frequency, we have to calculate the, we are going to get the frequencies, right? Then after getting frequency, we have to get the value of A and B. So by different values of voltage and frequencies, we are going to get the frequency later. And we all know that when P by F, which is equals to constant, what is the hysteresis loss component? WH is proportional to frequency, right? Like that, and eddy current loss is proportional to frequency square, right? This is case 1, right? This is the, since it is case 1. When V by F is constant, WH is proportional to frequency and eddy current loss is proportional to frequency square. That is, WH is nothing but AF and W is nothing but BF square. So these frequency values, these are the values that we are going to take for different rates. These are the values from readings. From readings we have taken. Then how to calculate A and B? So what about iron loss? That is summation of hysteresis plus eddy current loss, right? Which is equals to AF plus BF square. From this, F gets common, A plus frequency into B. So from this, the ratio of iron loss component to the frequency is equals to A plus frequency into some constant B. So from this we have to get the values of A and B. This is the equation we are going to get. So we have to draw the graph between iron loss component versus frequency and this. Okay, so this is the graph. So this is y-axis and this is x-axis. X-axis representation is nothing but F and y-axis representation is nothing but ratio of iron loss component to the frequency. And this is the constant of value A and this is the ramp signal. For example, here M is nothing but slope of the straight line which gives the value of B. Like that, the constant magnitude is nothing but A. Let us take Wi by F should be equals to A plus EF. If A is equals to 0, then Wi by F should be equals to, which is equals to what? A ramp signal only. That is, this is frequency, this is frequency, and the signal is what? Like this we are going to get. So this is the theta. From this we are going to get the value of B. So if A is equals to 0, this is the graph, but here A should be equals to some finite value. That's why the graph should be taken. That's why the graph should be taken from this point. So this is the graph if A is equals to 0. This is the graph if A is equals to finite, which is equals to constant value, right? For this is the graph. For this is the graph. Okay. So like this we are going to get the hysteresis and eddy current losses. Like this we have to separate the losses. Thank you.